Hello everyone, welcome back to our channel. In today's video, I'll be talking about how to plot powder XRD for an MOF. We all know MOF is called as a metal organic frameworks. So in this video, I'll be talking about metal organic frameworks. So these metal organic frameworks are class of compounds which has metal ions as well as the organic part. So these two form a cluster, or you call the porous material, and they have got very interesting properties and it can be used in very large number of applications. And this video is specifically for those who want to plot XRD graph and do analysis for MOFs. Why I'm talking about MOFs are crystalline MOFs or crystalline materials, but these also involves a tricky way to analyze it. Unlike metal oxides or other crystalline materials where it is used, powder XRD is used for analyzing it. For in case of MOF, it is the first necessary analysis in which a researcher or a student confirms what type of MOF someone has synthesized. So in today's video, I'll be talking about this. So before that, I would like to wish everyone International Day for Women's in Science. So today is Feb 11th, 2023. So this is a very special day. I'm so happy to put it on. And even today, I happen to answer a few doubts of students, and three people actually I clarified doubts, and two of them are girls. And all the doubts were basically related to MOFs. So I'm really happy, and I would assure you that this is a little long video because I'm going to go in a lot of details. We are going to use two softwares, and then I will also tell you how to find the softwares, where to find the software, how to download it, and how to plot a graph, and then to also to compare. For example, I'll be talking about how to plot a graph and then also to compare. In case of MOF, we do not have something called as a crystal data or the previously reported powder XRD. So therefore, we do not have any other reference platform to find the what is the MOF, what we synthesized is what we expected or not. For example, MIL-88B is a well-studied MOF, which we all know, it was developed from Professor Ferry, who was in Material Institute of Lavoisier, which is in France, and then he developed this material, which is called as MIL-88B. There are a lot of MILs. Like this is the 88 element, 88 MOF, and B stands for something else. So I have discussed this detail in the previous video, and still if you have details or if still if you have doubts, you can post it on the comment box or you can write email to me. No problem. I am really happy to help you all. And so we'll have to plot this data. So the black line is the experimental data, what is given here, so which is the MOF synthesized, and then we measure it. So it is not so easy to get such a data. And when you have a graph, or when I plot a graph, you would know from the operator, when you get the data, it is not as clean as this. We will have to do analysis of this. That is where problem lies. In most of the cases, even during my research, for the first 3 to 4 months, I thought I was not synthesizing a MOF. But later on, I found that I was synthesizing it, but the powder XRD is not clear because I did not give the proper scan rate. I did not give a slow scan rate. I did not instruct the operator what I wanted. Second mistake I did was I did not sit and analyze. I was expecting the graph to pop up the moment I plot, but data will not pop up. You will have to analyze it. You will have to do a baseline correction. You will have to do a peak picking, and you will have to find the corresponding crystal structure of this MIL-88 and then plot it on the graph. Suppose if you go and click it on the internet, the powder XRD of MOFs, you would find a lot of images showing that they have compared it with the synthesized structures. For example, in this, like one could be of the synthesized one, the other could be of the reported one. It goes on like that. So it says here in this, see, you could see that the first graph is the stimulated MOF, the second is the asynthesized. So which means all the three bottom here are synthesized by the student or the candidate, but the first one is the stimulated MOF. So the stimulated, getting of the stimulated data was very difficult for me to understand, and I have to get bits and pieces from everywhere. And then I do not know this is the right method, but this is the best method as of I know, because I have also in the course of time I have also contacted a lot of people who work on MOF, and I found that this is the best method to do to get this stimulated data. So for that you will be needing to perform all these to end up a final graph like this. One is the experimental data which you will get from the operator. The second would be the calculated data which you have to take it from the available sources and then make a powder XRD. So I will tell you in detail how to make it. So let's go to the data. First, we need two softwares. One is called as Origin. We all know Powder XRD is usually plot in Origin. There are also other plotting softwares, but Origin is usually preferred. I do not know if something else is better, but to my experience for plotting the Powder XRD or any simple such kind of an analysis, I feel Origin is very handy. I have also worked with JMP. I have also worked with other software. I forgot the name, but as far as when it comes to Powder XRD, I would prefer Origin. The second software is called as Mercury. So Mercury is a software which is basically to view the crystal structure of of a material. So first, you can download the free version for the students in Origin Lab, which is for 6 months. If you have an email ID which consists of .edu, your email ID ends with .edu, you can go to this, you can type Origins for student version, and then you can go to this link, and then you will have to enter your credentials for student, and there would be, when you go on, this would be waived off, and you would have a free software, or you can go to this try Origin for free, where you would be requiring to, it is giving like which best describes you. You can choose whatever you want, or I never used Origin. You are a student or government, you give a student, academic or government. Let's say like we'll give it as a student. It will ask you for a version of this thing. Student version costs less, and it is so Origin Pro Learning Edition. So this is free. The cost is valid with a valid university email ID. This is free, and the expiry license is 10 years. So the expiry license of expiry is 6 months. So you would have it for free, so that it is easy for you to use. Second thing is like so you can download this Origin. The second thing is like Mercury. Mercury also, you type a keyword like Mercury software for free download, or you can just type it as Mercury software. And please do not download any proxy software, because like it may destroy your computer, because we all know now phishing has been a very important threat to everybody. And please go to a official site and download the proper software, even if it is a free version. I know like getting into crack version is easy, but it is not advisable, because I know personally like few of my friends who lost their whole data, and then they struggled a lot to get back all the datas, and in some cases like they were backed up in the cloud, something like that, so they were able to recover. If not, when it goes into a ransomware, your data are lost. So I will also advise you to keep all your data backed up always, at least once in a month, in a separate drive where you do not access internet. So let's go to here. Sorry for an advice. So there are also like different softwares like Mercury.software information, Mercury.com. All these are not. CCDC is the official sites who provide software. So you go to this, click here, and you can try browsing it everywhere, home solutions and all. But I would tell you the best way to save your time, go down all the way to bottom. There is something that's called as download the CSD data on software, and this page pops up. In this you click direct download. You click it, there would be an additional window opening up. Come down slowly, slowly, slowly. Oh, I missed it somewhere. There should be an Origin. Ah, yes, here is a Mercury. So it goes Mercury incorporated, that one, and here it goes UHO. So this is a free version. You will not have access to all the services, but this is a free version which is enough for us to perform the what we wanted. If you are a crystallographer or if you work hardcore on crystallography, you can prefer buying it an upgraded version where you would have a lot of things. And I have downloaded this version which is called as this one. Have where I have not downloaded it. So these are the two things which we needed, two softwares which we needed. One is the Origin, the second is the Mercury. Do not forget. So before doing this, or you can pause the video, go back, download these both, and then come back, start the video. Also remember that if you feel any difficulty in downloading these, or if you think that you are not able to access the free version, please feel to put your email ID on the chat box or the comment section. I will write back to you. Also, there will be an email ID available. So if you have any difficulties in this accessing this software, please feel free to write. And I do it for, I don't charge anything because I know how much struggles I have gone through in learning of what MOF is and how to get all these things and publish papers and do all these MOFs is really. I know like people who have experienced it is easy for them, but to start with when you are a initial researcher, it is very, very because when I was starting, there was no other people in the lab who does it on MOF. I do not know whom to ask. It was a really tricky thing to keep searching for the ideas and get and then implement it in our experiments as well as this analysis and but sorry, I'll directly go to this. I think like this is the first video where I talk a lot about than it is. So I'm opening a new origin and then will import something. This is the so you can go import and you can do a single ASCII here, or there is always a shortcut here. This one where you have this 123 and single one. So it is import single ASCII. I just click, it will go to the previous open folder. I'm going to load the XRD data which I got it, which is MIL-88B. Since I know it, I know this is an MIL-88B. So these are the sample details like what is the continuous scanning, what is this shift, what is the rate, everything is here. So what I'm going to do, I'm going to delete all this. So this is the start value, this is the stop value, and this is the step size, which is also called as scan rate. So these are not needed for plotting. So I'm going to delete this just like that, and then plot. Plot. It is not as beautiful as we like it. So now we'll have to do some tailoring effect. First I go here, smoothen it, analysis, signal processing, smooth, open dialog box. Not the last used one because we do not know what was the last graph you plot. So you have to give auto preview. If you are using an advanced origin version, you would be having a better results. I mean the better what do you call this user interface as well as the graphics. So, but technically these would be the same thing. So I'm going to give 15 and click on the graph. Seems good. Yes, I would see that all the peaks are there and it is very good. Okay. So now it is smoothened. I'm going to remove the previous data. This. Now we see that this is a baseline here and there is a baseline difference. So we'll have to do a baseline correction first. So I go to analysis again, peak and baseline, peak analyzer, open dialog box. So remember it is analysis, peaks and baseline, analyzer, and then open dialog box. There will be a window popping up. To create a baseline first, I'm going to create a baseline. Next, then it shows that the number of points to find is 8. Let me give 8 on find. There are also one video of I have previously done it on detailed on baseline corrections. I do not want it to take up a lot of time because we have got a lot of things to do. I wanted to finish off the video in at least 15 to 30 minutes. Find, I'm not satisfied with the baseline. I'll do a correction. I'll give next. What I'm going to do, I'm going to add points. So this is not the exact baseline I wanted it. I'm going to add a points. So let's say like this would be the first point, and this would be the second point, and this would be the third point, fourth point, and this would be the fifth point. You can put as many good baselines as you want so that your baseline is much more proper. Done. And I also wanted to edit few. This one I'm going to give modify and delete. Click on this and then just pull it down a little. So I'm just pressing the down arrow, not doing anything else. So I want the baseline to be here, and yes, I want to move this baseline down. Use the arrow keys, nothing else. Once you get this cross mark, if you wanted to make this cross mark big, keep pressing the space bar. You would make this cross mark bigger. So everything is done. I just wanted to include one more point here so that the baseline is right. Here also I'm putting it and done. Wanted to add one more point which is here so that double click it. So you have added 1 point. So now you see the baseline is different. Now I'm going to give finish. When I give finish, there is a baseline generated. So to make the visibility, the color of this, or no, blue is my favorite color. So you could see this is the previous peak and this is the baseline created. Now you go to your workbook and this is the new baseline. Put a new column. Column property, you have to go to column, set the column value, set column value. Yes, here. Set column value. The shortcut is Control Q. We are going to minus the old data, which is the column B, subtracted with the column E. I'm going to give OK. Plot this against A against F. I'm going to put a line graph. You could see beautifully done. So now the previous graph looks like this and the new graph looks like this. You've got a beautiful baseline. Yes, nice. Now I need to again smoothen it. Going to do analysis, signal, one dialog box. I'm used to this, so I'm doing it fast so that I do not waste much of your time if you are looking for a specific detail to look into. I think I still wanted to smoothen it a little bit because why I'll tell you, because you could see the lines are still zigzag. The red lines, like these red lines are still zigzag. I wanted it to be a little more straight, so I'm going to give it 20. So remove this. Check is removing. Put it here. In this, let's say like favorite colors, or let's say like violet, little thick. Bingo, it is beautiful. So you imagine the first graph was like this, or and now this is like this. Unimaginably beautiful and unimaginably good. This is what now you can know your now your data is good. The previous data what we plotted like this, just like this. So this and these are a very huge difference by side. This and this are very huge. Someone you could see that the third peak here pops up very clearly. Here the third peak is not proper. Here you could see there is a doublet peak, I mean a pair of peaks coming out around 20. Here these are coming up, there is an additional peak coming up here. So this is what we have to. The second thing is you need to download crystal data. Go to Google and type, and this is MIL-88B FE, and just give SIF. That's it. MIL-88B, and what is the MOF you want, and then SIF. Press enter. Go to yes, and go to this crystallography.net, and not this. If you go to this also, if you go to this also, I just go to this, not this nanocrystal technology. Go to this crystallography.net. Enter, and there is a data. It is like MIL-88B topology. There are different zip files available. I'm going to download this zip file. Just click here, it downloads, and I'm just going to give or show in folder. Bring up a folder. Just give open when it is done. Open. It will be opening in the Mercury software. I'm also using a free version which I downloaded it officially. Pops up. Yes, it is popping up now. Restarting. Copy of Mercury is now out of date to buy if I want to. This is the MOF pops off. This is the single unit of MOF where all these three units are called as what do you call the polyhedra, or this is in. So this is according to my model where you get this beautiful polyhedra. If you wanted to see the packing, we just give packing, whole packing. If you wanted to see it along A, along B, along A star, B star, along C star, you could see beautiful arrangement. White. Okay. So now we need to have this powder XRD data for this crystal. How to generate this? Is go here. There is something called as powder. So this is basically powder XRD. Since I'm going to click here, it generates a powder XRD data. Beautiful. And you don't have to do anything. If you can, you have to customize this according to your angle, the wavelength in which your XRD was performed, and what is the theta values you needed, and what is the step size. In our case, the step size is 0.3. Scale is from 3 to 5. It was K alpha, I mean copper K alpha, which is 1.5 Armstrong. I know it, so I'm doing it. And check your what do you call it? Check your data, and if the wavelengths are different, please find it, because for example, if I'm going to put 0.3, the XRD would be completely different. Let's see, the XRD is completely different. Only when it is 0.5, this is going to be different. You see, there is a shift in the peak. In that case, like, you have to put what is your step size. Suppose if I'm step size is 0.5, XRD would look slightly different. See, my step size is 0.05. So it depends. So you'll have to have a comparable XRD data. I'm just going to give OK, and now come to save. This is save as, save image and save as. When you save as, open this, and we need to save. There are three to four different files. You have to save it as tab separate .stv, which will be accessible by the origin file. I'm just going to OK, close this, try this, go to origin, the new ASCII, and then this is the what we know. Now what I'm going to do, I'm going to rename these files whenever you need it. Copy this, put it here, columns. Or you can also put as experimental, as calculated, something else, or stimulated, all these things. You have to plot this. So now what you have to do is all these should be y, because this is the final data which we are going to plot, and this is y3 and this is x1. So this will create a little confusion. So I'm going to change this into, how I did it is, sorry, I'm going to get a right click, right click, select the column and right click and set as status. I'm going to make this column as y and similarly this column as y. So that now I am plotting x with y, and this should be an x. So and this should be x. I'm doing it plot as x. So now this is x1 and y1, x2 and y2. I'm going to copy this, x1, y1, x2, y2. Yes, all these are copied. Now if you go to plot a line graph, this would look a little different. I just wanted to show you. The intensity of the one data stimulated is very high, but the intensity of our peak is very, very small. So I do not wanted to do this. I wanted to plot a double Y so that both the intensities are intact. So I'm going here, a double Y. This looks like this. Do not worry, it is easy to correct it. Click on the data, and then here you see lines and symbol. Instead of lines and symbol, put it line, and then just give I, and first layer, it also shows line and symbol. Put it in the line, give OK. It turns back into a different graph. Now what we have to do, I have to minimize this so that it comes halfway here. I'm going to double the scale up. Yes, the intensity. Adjust 100 at minus 150. One six. I think so. Now we could see that we have attained a graph. So this is here and this is above. I have just adjusted the scale. Now no more the scale is valid because we are just comparing the intensities and the peak position. Now we know there is one peak corresponding here and there are two other peaks which is corresponding here, and we could see that this is screen reader. Click it, space bar again, or this will become larger. For example, this. There is a small shift in the peak. How to shift this towards left? Click arrow, point it out here, and active. I'm going to click this and then go to analysis, data manipulation, and then have to do a horizontal translation. And you know horizontal translation is, I'm just going to move it a little bit so that there is a small difference in the peak positions because both are analyzed in a different method. One was a single crystal XRD which is specific, one was powder XRD which is less specific. I'm going to just move it a little bit. Yes, move it a little bit where. So now if I'm going to put a screen reader and on this peak, still need to be moved a little bit. Sorry. So I have moved it, and now you can generate a data. Spectrum. Put here as none, major tricks as well as minor tricks. Applied. Clean. Not one none because the scale is no more valid because we have got two different intensity. Looks good. Give the corresponding XRD, sorry, x-axis and y-axis to theta. So to put theta, you put control M, you would get a symbol map. Bracket 3, again control M. Intensity, arbitrary units. Always put the units in the bracket of your thing. Good. Double click. Make this to be a presentable one. Everybody to clearly. Yes, double click. Control E, select all. Hold 24. And then garnish this. Put a thicker line so that when there is a smaller color to red, it is contrast, so it looks good. If you want the shadow to be there, it can be. Let's say like the red is stimulated. The one black one is synthesized, or yes, synthesized. That is space. I do not want this black shadow, so I'm going to give a right click. Properties. It shows shadow. I do not want 999. Okay. If you wanted a box, you can still click on properties, right click on properties, and then if black line, there will be a black outer box showing. Oh, yes. P within bracket the metal is iron, because there are also other metals like chromium available for select all, which is control A, little bold and make because title. And now we have generated a data, but these data are not little comparable. I think like the actual data of this and this is, there is a little mismatch. So now we know that the actual data what I synthesized was not similar to this. Just looking at this data, it is very difficult for you to compare. So that is why when in case of MOF, people plot it like this: the stimulated one or the one which is calculated and the synthesized. So when you plot this, you will know how to do it. So maybe now it is initially time taking, so that you may think that it is a long process, but if you do not do this for your graph, you are going to miss a lot of things. Means like sometimes you would have discovered a new morph, sometimes the morph is really new, you may not know there is a new morphology, and for that, like, you need to know it so that it is not elsewhere reported. And in sometimes like MIL-88B as well as MIL-53, both have got a similar procedure to synthesize, and if you change a small things in the procedure, and you would be ending up in a different thing, not an MIL-88B. In this case, like, this stimulated one is from the crystallography, so we know this is MIL-88B, and definitely the upper one is not MIL-88. This is like comparison, and the actual result is it is not. So it is the data which I got it. It is an old data, so it is not. So by now I know I have not compared it. If I just have this graph and look at the powder data of this, it may look similar. There are two peaks at 10. There are two peaks at 10, and still I have some two peaks at near 10. There are peak below around 7, and here is also there is a peak around 7. Yes, 7.5. There is a similarity, but I think like sometime it is similar but it is not same. So similar and same are different. So this may be due to that, since the synthesis procedure was also followed similar to that of MIL-88B, you would be knowing that there are a lot of pores inside a metal organic frameworks. So there would be a solvent molecule present inside. So when you do not heat it up in the vacuum treat it and then remove all the solvent, you may have a distortion in the crystallography, or you may have distortion in the crystal structure. That is the reason where it is similar but not same. So sometimes you need to do a solvent exchange process, because of which you may generate a good quality MOF. So because the pores has to be open, the solvent molecules or the anions has to come out of the pores. In case of MIL-88B, there is an in situ anion as well as solvent molecule sitting inside. So this may create it, so which needs a proper drying procedure, which needs a proper solvent exchange procedure. So I especially took this to show that young people who are coming up doing MOF research as to, this is the first priority, that they should understand the powder XRD of the material, so that it is easy for them to move forward. You cannot compare two MOFs with IR. IR may give the same MOF. For example, the ingredients of MIL-53 as well as MIL-101 and MIL-88B are same. All three have iron, all three have benzene dicarboxylic acid, as well as the synthesis procedures are little different. That's it, very little difference. Temperature and solvents are different. So in IR gives all same the functional peaks, but XRD gives you the difference actually. So there will be a difference in the IR, but it is not so explicitly seen. But in case of XRD, it is very explicitly seen, and this is the primary analysis of a MOF where someone has to do it. So I hope that you would now be analyzing powder XRD of your MOF much better. In some cases, the baseline would be very bad, and if you could, there was a video posted on the same channel, that is the baseline correction of MOF. So that baseline correction, what the crystal data the powder XRD data used was of MIL-88B chromium. So you could go and see that the peaks are not easy to visible. So peaks are not easily visible. So the baselines are wide. sometimes the MOFs have a very different, less, more distortion, because the crystallinity is not so good, because MOF is not a metal oxide, so to be high crystalline, it consists of a metal as well as an organic part, which makes to be a crystalline but not highly crystalline as compared to the metals and metal oxides. So analyzing MOFs are very tricky, as well as you do not have the standard database for powder XRD. So it is, thus you do not know the HKL values. You need to compare the stimulated patterns or the calculated patterns and then do it. And I think this is my one of the old datas available. And here you could see that the peaks match so perfectly that there are two intensities. The intensities are like this: one is smaller, one is higher. So here is also one is smaller, one is higher. There are the other peaks, and sometimes it is not necessary that all peaks are matching. So I can move this. I move this by moving the arrow. This peak is matching, and there is no peak here in the stimulated data, whereas this peak is matching and the other peak is matching, and this peak is not there in the stimulated data, which means that these extra peaks are due to the impurities or the solvent molecules present inside the pores of the MOF. You should also understand this. The impurities can be usually solvent molecules or the cations, not cations, anions present in them, in this case MIL-88B. So some, see, this peak is available in the stimulated pattern but not in the synthesized one, and the peak intensities are also different. So the major peak intensities are this, which is around 10. So these are the important peaks which needs to match superbly, because you see, suppose if I get a data where the first peak is around 8 is higher and after 10 is smaller, though they may be in the same position, but the morphology or the topology varies. You should know that. So the peak size or the intensity does matter here. Okay, I think I have conveyed my best. This should be really helpful. Thank you. If you have been so long here, thank you for being here. I hope I have made your day useful. Thank you. Follow us for more such useful videos on MOFs, as well as on powder XRD, as also something related to material characteristics. Thank you.